Okay, this is a tutorial on electrolysis. You may have noticed the fancy, very neat heading. Uh, Now I'm gonna be doing just the first part of it, which is just the basics. You probably come across the topic in, I think, grade 8 or 9, one of them. As you would probably know by now, it's just a process where you have an electrolyte. Stick this as a flask or something. This is your electrolyte. It's usually in a molten or a liquidish state, and you pass current through it via a battery. You have a cathode and an anode. That's a positive terminal, negative terminal, and you have over here is the anode, and here is the cathode. What happens is that as the current flows from the positive to the negative terminal, it ionizes the electrolyte and breaks it up into its ions. So if you have NaCl, the electric current passes through it and it breaks up into Na plus and Cl minus. Now these two get separated in the electrolyte. I'm just going to draw a bigger version. Change color. I'm going to draw the cathode with red and the anode will be green. Now cathode is connected to the negative terminal. Okay, so I'm just gonna mark them, anode and cathode here, and you can see in this diagram as well, cathode is connected to the negative terminal. So disconnect this here and positive terminal over here. Okay, so since anode is connected to positive terminal, what happens is that let's take NaCl breaking up, for instance. You have Na as the positive ion and you have Cl as the negative ion. So in order to gain stability, lose an electron, Cl needs to lose an electron. The Cl ions in the electrolyte. So in the electrolyte you have these Cl minus ions. So these of course need to lose their electron. So all of these migrate towards the anode and just get stuck on it and lose the electron, become stable. At the same time, the NaCl is also broken up into Na plus. Na is plus, it has an excess positive charge, so it needs one more electron to become stable. And since the cathode is connected to the negative terminal, the Na moves towards the cathode. So these are the basics. All you need to remember is cathode goes with the negative terminal, and don't get confused with cathode and cation, because the cations go towards the cathode. So write this. Cations are positive ions like Na, and the cations, in order to become stable, move towards the cathode. And it's the opposite for anions and the anode. These are just the basics, and after this you're probably going to study a few specific electrolytes in more detail. Also, you should note the difference between solid NaCl, aqueous, and molten. Okay, so what happens is that solid NaCl, if your electrolyte was solid NaCl, then none of this would have happened. This process would not have taken place. And that's simply because in the solid state there are no free ions which are there to conduct this electricity coming through. Because in the solid state, As you might have learned in chemical bonding already, the compound NaCl is a very strong electrovalent bond, ionic bond between Na plus and Cl minus. And since these are opposites, there's a plus and there's a minus here, there's a very strong electrostatic force in between them. So as a result, there are virtually no free ions available in this state. You'll have nothing to conduct the electricity through. Um, so when you have solid NaCl, this will not take place, this whole process. Now since there are no mobile ions that can move around, what you do is you actually provide a bit of energy to this whole compound of NaCl. Just gonna take a different color now. So to break this bond, you need a certain amount of energy to break this. When you provide that energy, this bond breaks and you have Na plus ions and Cl minus ions that move separately in different ways. So in that case, when you do have free ions, these Na plus and Cl minus ions can carry the electricity that's coming through. So that is basically why molten and aqueous sodium chloride do conduct electricity. Molten state, as the word suggests, it's melted, it's partially melted, sodium chloride. So in order to melt, of course, you need to provide energy in the form of heat. So once you've provided that, sorry, that's melt, not held. This is heat here, heat energy. So in this case, you need energy. Over here, you've got energy in the form of heat. So when you do that, this bond between sodium and chlorine, this weakens. It doesn't break up completely, but it weakens. If this is a bond, it perhaps becomes something like just this, just a representation. Doesn't mean anything. 2 and 3 doesn't mean anything. And so when the bond becomes weaker, you can imagine that the Na and Cl are no longer held very tightly together, and this means that they can move around, at least comparatively, compared to the situation where there was no energy being provided in solid NaCl. So once there are mobile ions that can move around and conduct electricity, that's when electrolysis takes place. Now in aqueous sodium chloride, the word aqueous, just gonna change color again. Aqueous means that the compound is dissolved in water. So you have water over here, and aqueous NaCl would be that, uh, just suppose that these green dots are NaCl and you put them in and they dissolve to form some solution. So this is aqueous NaCl. Now you're going to learn this later in one of the later chapters, that water is a polar solvent, and it has a property, it has a high dielectric constant. High dielectric constant. So you don't need to know much here, just know what it means. It's basically that the compound H2O, it tends to break other bonds. So when you have an Na plus and Cl minus bonded strongly, if you dissolve it in water, what the water tries to do is actually break these into Na plus and Cl minus. That property is due to its high dielectric constant. There are other substances as well, but this is the most common one. So just know this for now. So just to summarize all of this, I'm just gonna go over the whole mechanism of electrolysis right now. Just gonna erase this. So two electrodes. electrodes are those rods or plates, you could call them, that carry the current. Uh, they're actually submerged in the electrolyte, so they carry the current from and to the battery outside, uh, and into and out of the electrolyte. The substance that is inside the container or the bowl or the flask, whatever you want to call it, is the electrolyte. Electrolyte, as I've told you, usually in molten or aqueous state. The reason as well I've told you, and the reason for that I've told you, for aqueous it's because of water's high dielectric constant. The reason for that I've told you, for aqueous it's because of water's high dielectric constant, and for molten it's that to get something in the molten state you need to provide it heat energy, and once you do that you loosen the bond between the two ions, so you have free mobile ions. Okay, so okay, so suppose this is your electrolyte over here. Let's take NaCl as the simplest example. So NaCl, composed of Na cations and Cl anion, sorry. Okay, in this state over here it is NaCl. Just let's just take this as a molten state. So it's still NaCl. The bond is loose between them, but it is still NaCl. Okay. So now we'll draw the anode and the cathode. This is the cathode connected to the negative terminal, and here you have the positive terminal. Anode here. You'll be learning more about cathodes, anodes, what are they made of, later in the second section in this chapter, but for now just take it like this. I'm just going to change color. Just going to change color. Okay, so what happens is that let's just imagine how the process would go like. Current starts flowing over here, goes to the anode, no problem here, and as we just learned, since this is molten, we're taking in this example molten NaCl. So since the bonds are weak, we do have free mobile ions that can move around. So Na and Cl, in order to conduct the electricity, break up and give us these two. So Na, we have Na plus and Cl minus. Now just imagine that this NaCl over here, let's just cut this out, and instead of this, as the current starts flowing, it breaks up into Na plus Cl minus. So for now just imagine that there are little anions and cations of Na and Cl just floating around in this substance. Now of course, since these are both ions and this one is positive, this one is negative, so this one wants to gain an electron so that it goes back to its former state, gain, and this one wants to lose. Now you look at these two ions in this electrolyte are really free to move, they can go anywhere. Now look at the cathode, it's connected to negative, so it has electrons available, and the one that wants electrons is Na plus, which is a cation. It wants to gain electrons. and this one does have electrons. So the Na plus get to the cathode, gain an electron, and are happy. Opposite happens for the anode. The anode doesn't have too many, so the anode wants to gain so that this plus becomes stable, while the Cl minus, they are already minus, so they want to lose. So these two form a pair, and Cl goes here. That's all there really is. These two are discharged at their respective cathode anode. Cathode is connected to negative. It's slightly confusing because the word cation and cathode, all these words are associated with positive usually. Um, Cation is of course positive, so these two form a pair, and vice versa for anode. So this is just the mechanism of electrolysis. This is a pretty simple case over here we've taken. Later you'll be learning more complex cases. And also one more thing, when you write the reaction, you write as a reversible reaction. You would have seen this symbol in some places. This basically means that this reaction can be reversed. The Na and Cl minus can combine back into NaCl. Also, the reaction at the cathode would look something like this. Na plus, that's the ion, it adds one electron and it becomes Na. Meanwhile, at the anode, what you get is Cl minus minus one electron gives you Cl. And after this, since Cl is a diatomic gas, you'll be learning more about that as well. Cl plus Cl gives you Cl2. So just imagine that once this reaction takes place at the anode, you have loads of Cl just sitting around doing nothing. So all of them pair up and form Cl2, which is its natural state. And then of course they're all released up over here. So that's all there really is. Electrolysis, to sum up again, just the definition, it's a process where any substance, which is called the electrolyte, is broken up into its ions that it's composed of via electric current. That's the basis of this chapter. Okay, so we'll be back for the next section. Okay, and in the next section we'll be dealing with certain cases, certain electrolytes. So see you then.